Hello students, in this video lecture we are going to evaluate the inverse Laplace transform using partial fractions. Now here we have problem 1 which says evaluate inverse Laplace transform of 1 by s multiplied with s plus 1 multiplied with s plus 2. So the terms inside the bracket can be simplified by using partial fraction so that we can use the linearity property and apply the inverse Laplace transform to it. So first we will separate these terms by using partial fractions. So first I have taken the terms which is there inside the bracket and I have written separately. Now this can be separated by using capital A divided by the first term, that is S, plus capital B divided by the second term, which is S plus 1, plus capital C divided by S plus 2. So we have separated the denominators by using partial fractions. Now we have to evaluate the value of A, B and C. So in order to do that, we will be taking the LCM on the right. So what will be the LCM? It will be S multiplied with S plus 1 multiplied with S plus 2. And so here already we have S. So the remaining terms has to be multiplied with A. So A multiplied with S plus 1 multiplied with S plus 2 plus the term B has to be multiplied with, we already have S plus 1. So it has to be multiplied with S and S plus 2. So S and S plus 2. And finally, C has to be multiplied with, we already have S plus 2. So the remaining other two terms, that is, it has to be multiplied with S and S plus 1. So on the left, we have 1 divided by S multiplied with S plus 1 multiplied with S plus 2. Now since both the denominators are same, the terms in the denominator gets cancelled. And so therefore, we will have 1 to be equal to these terms. So I have taken and I have written that. Now in order to evaluate the values of A, B and C, we have to first put S is equal to, so if we choose S to be 0, these terms will become 0 since it is multiplied with S. So what we will do, we will put S is equal to 0 so that we will get the value of A when these two terms become 0. So on the left we have 1 which is equal to A multiplied with S is 0. So 0 plus 1, it is 1. And here S is 0, so 0 plus 2, it is 2. Plus this term becomes 0 since we have we have taken S as 0. When B is multiplied with 0, this complete term becomes B 0 and also this term becomes 0. So finally we have 1 to be equal to, so A multiplied with 1 which is A. So again multiplied with 2, it will give us 2A. So from this we get the value of A to be equal to 1 divided by 2. So the value of A is 1 by 2. Now next we have to find the value of B, for which we have to make the other two terms 0. So the term which is common to A and C is S plus 1. So if we put S is equal to minus 1, this term becomes 0 and also this becomes 0. So the next step is we have to put S to be equal to minus 1. So what will happen? 1 will be equal to A multiplied with minus 1 plus 1 will become 0 and so this full term will become 0. And then for this term, plus B multiplied with S is minus 1 and here we have S plus 2, so minus 1 plus 2. And then when we put S as minus 1, so minus 1 plus 1, this term becomes 0. So therefore this complete term becomes 0. And so 1 will be equal to, now here we will have B multiplied with minus 1 multiplied with, what is minus 1 plus 2? It is 1. So from this we get the value of B to be equal to minus 1. So we have obtained the value of B. Now in a similar manner, we have to obtain the value of c. So if we want the value of c, we want to make the terms of a and b as 0, for which the common two terms are s plus 2. So we have to put s is equal to minus 2. So that minus 2 plus 2, this will become 0, and here also minus 2 plus 2, these terms will become 0. So put s is equal to minus 2. So 1 will be equal to, so this term completely becomes 0, this also completely becomes 0, and finally we have c multiplied with minus 2 multiplied with s plus 1, so minus 2 plus 1. So therefore 1 will be equal to c, what is this, c multiplied with minus 2, and this is minus 2 plus 1 is minus 1. So minus into minus, it will become plus. So from this we get the value of c to be equal to, this 2 goes to the other side, and so we get c to be equal to 1 by 2. So we have obtained the value of a as 1 by 2, b as minus 1, and c as 1 by 2. Now we should substitute these values of a, b and c in this, that is, let us mark this as equation 1. So we should substitute the values of a, b, c in this equation, so that we will get whatever was there inside the bracket of the inverse Laplace transform. So let us substitute in that. So therefore what we get is 1 divided by s multiplied with s plus 1 multiplied with s plus 2 is equal to what? First we have a divided by s. A is 1 by 2. So 1 by 2 divided by s plus, next what we have, b divided by s plus 1. What is b? b is minus 1. So minus 1 divided by s plus 1. And then what do we have? C divided by s plus 2. What is the value of c? C is 1 by 2. So plus 1 by 2 divided by s plus 2. Now we shall take inverse Laplace transform on both the sides. So if we take inverse Laplace transform, we will be getting inverse Laplace transform of, on the left we have 1 divided by s multiplied with s plus 1 multiplied with s plus 2, which is the given question, and that is equal to inverse Laplace transform of the first term. Now 1 by 2 is a constant, so 1 by 2 we will write out. So we will have inverse Laplace transform of 1 by s, and then we have a minus 1, so we can write minus inverse Laplace transform of 1 by s plus 1, and then plus this 1 by 2 is a constant, and then inverse Laplace transform of 1 by s plus 2. So now we have to find the inverse Laplace transform of these terms by using the formulas under inverse Laplace transform. So let us see that. So by the formulas we know that the inverse Laplace transform of 1 by s is equal to 1, and the inverse Laplace transform of 1 by s plus a is e to the power minus at. Now we will apply these formulas over here. What is the first one? That is, the inverse Laplace transform of the given question is equal to, first is 1 by 2 inverse Laplace transform of 1 by s. So it will be 1 by 2 multiplied with 1, because the inverse Laplace transform of 1 by s is 1. And the second term we have minus inverse Laplace transform of 1 by s plus 1. Here the 1 is the value of a in the formula. That is, we know that inverse Laplace transform of 1 by s plus a is e to the power minus at. Now we want inverse Laplace transform of 1 by s plus 1, which means the value of a is 1, and so here we have minus, so I am writing that minus. See, minus, what will be the inverse Laplace transform of 1 by s plus 1? It will be e to the power minus, here if we put 1, it will be e to the power minus t. And the third term is, here we have 1 plus 1 by 2 inverse Laplace transform of 1 by s plus 2. So that is, the value of a is 2 now. So what will be the answer? E to the power minus 2t. So plus e, we have a 1 by 2 constant over here. So this 1 by 2 we will write, and then So 1 by 2 e to the power minus 2t, because now we have the value of a as 2. So therefore the final answer is 1 by 2 minus e to the power minus t plus 1 by 2 e to the power minus 2t. So hope you have understood how to evaluate inverse Laplace transform using partial fractions. For problem 2, follow the next video lecture. Thank you.